The workman has completed disassembling, cleaning, and inspecting the pump. If any of the measurements had been out of specification, the necessary repairs would have been made. In this case, all measurements met the manufacturer's specifications, so the workman is ready to begin pump reassembly. The first step is to press the bearings back onto the shaft. Next, he places the lock washer on the shaft. He makes sure the tab fits properly in the keyway. This prevents the washer from turning. Then he threads the lock nut onto the shaft. He continues threading until it is hand tight. With that done, he places the impeller wrench on the shaft. This is to hold the shaft steady as the lock nut is tightened. The workman uses a spanner wrench to tighten the lock nut securely, holding the wrench tightly to prevent slippage and possible damage. With the lock nut tightened, the workman removes the impeller wrench. He then turns the shaft to find the tab on the lock washer, which is lined up properly with a key slot on the lock nut. Using a pin punch and hammer, he drives the tab over the nut, locking it into position. Next, a cone is threaded into the end of the shaft. This allows the seals to slide over the shaft easily, preventing them from being damaged. The shaft and bearings are now ready to be installed into the bearing housing. They must be eased into the housing. The bearings fit snugly, so be careful not to cock the shaft. That could jam the bearings, possibly causing damage. Care must be taken as the cone slides through the inboard oil seal. The oil seal has a press fit and is replaced each time the pump is disassembled. With the shaft in place, the workman installs the snap ring. He slides the ring over the shaft. Then he uses pliers to open the ring to allow it to slide over the bearing and into its slot. The shaft is then pushed forward as far as possible. This seats the snap ring against the bearing housing. Next, the deflector ring is installed. The workman slides it over the shaft and up against the inboard oil seal. If it's not positioned properly, it won't keep other fluids away from the oil seals. As a result, these fluids could enter the bearing housing and cause bearing damage. With the deflector in place, the workman places the gland follower on the shaft. Be sure it is put on so the gland throat faces away from the bearings, toward you. Next, he installs the end plate. The end plate must be put on with the gland seal hole at the top and the cap screw bolt holes properly lined up. This is to allow the cap screws to be installed and threaded into the end plate. If it is possible to install the end plate on a pump you're working on in more than one way, match mark it before you remove it. That way you can make sure it goes back on the same way it came off. There's no gasket between the end plate and the bearing housing adapter. This is because these mating surfaces don't form a sealing surface. When the cap screws are hand tight, the workman uses a wrench and alternately tightens them evenly. Next, he removes the cone on the end of the shaft. This allows the impeller to be installed. Take care when threading the impeller onto the shaft. As with most threaded fasteners, spinning it on may cause thread damage such as galling. If this occurs, the threads on both pieces would have to be repaired. You may have to hold the shaft to prevent it from turning. Once the impeller is hand tight, the workman slides the impeller wrench onto the shaft. Then he rotates the shaft with the wrench. As before, the wrench stops the shaft while the impeller tries to continue rotating. In this case, the impeller tightens as it rotates. The impeller will tighten itself further when the pump is run. With the impeller installed, the next step is to set the impeller clearance. But before the workman gets to that, I'd like you to stop the tape and review your text. The workman is now ready to set the running clearance of the impeller. This clearance is very important because it affects the pumping characteristics of the pump. If there is insufficient clearance, the pump will pump below capacity, or it may not pump at all. Let's join the workman. Watch as he sets the running clearance of the impeller. Remember, the shaft has been pushed all the way into the bearing housing. The workman uses a feeler gauge to measure the clearance or distance between the impeller and the end plate. The feeler gauge should fit snugly, but not have to be forced into the space. You may have to try several combinations of blades. When the clearance has been determined with the feeler gauge, the workman then uses a micrometer to check the total thickness of the feeler gauge blades. Even though the feeler gauge blades have thickness measurements on them, you might have more blades than you realize. So by using a micrometer, you can be sure that your measurement is right. The clearance, which in this case is 92 thousandths, is recorded. Next, the workman checks the manufacturer's instruction manual. In the manual, he finds out that the clearance required for the service this pump will perform is 21 thousandths. This means that right now he's got too much clearance. He can reduce this clearance by adding shims. To find out how much shim thickness to add, he subtracted the two figures. This gave him the additional shim thickness required, 71 thousandths. Shims are supplied by the manufacturer in various thicknesses. The workman measures each shim thickness. Then he selects the combination that will add up to his desired thickness